1, Lesson 3 to be taught on Thursday, 8/22. Same standard as the last 2 days, 4.0.4, which is working with multiples and factors. The only difference today is the word all is the key component. So finding all factor pairs, which is reinforced with the achieving first aim. Mathematicians will be able to find all. I literally wrote all again. Factors of a given number by creating factor rainbows. We are going to call them T-charts, and we're going to show them one factor rainbow, and then we're going to do T-charts because they are stronger. The biggest thing that you need to take away when you read and annotate this section is the word consecutively. That is what we're going after today. And our today, tomorrow, and everyday statement is the same today. I know a number is a factor when we, or I, can multiply it with another number to find the given product. It's not enough to be able to say this. It has to be within action of understanding that 5 is a factor of 5, that 5, oh my goodness, I messed that up. I'm going in multiples, that's embarrassing. That 5 is a factor of 10, that 2 is a factor of 10, because together we can multiply them to get to that product. I also know that 1 is a factor of 10 because 1 times 10 equals 10 and 10 times 1 equals 10. So both are factors to get to that product. This is missing big problems, tasks, and complete sentence answers as you go through this. I do really like how they wrote this out, I do really like how they wrote this out. It's neat. I had a hard time with that when I was going through the IVP process, keeping my work neat. And I think it's partially because their rainbows are skinnier and my T-charts are long, so that takes away a little bit of the room. This factor pair, it has to be both this and the 18 times 1. Okay. All right. I went through, I started thinking through what are the representations I want, where are the key points coming out. I underlined and circled things that were important to me because I annotated. I started here today because I wanted to get comfortable with what I was going after, but I'm gonna model the problem about Jared. Jared has 18 flowers. He wants to plant them all in equal rows in his garden. What are the different ways he can arrange the flowers in equal rows? Because this is a word problem, I'm gonna annotate. The big question is all, underline that, diff ways arrange 18 flowers equally. Good. Okay. Representation. Oh my goodness, how embarrassing. Task 1. Identify product. And then task 2, test factors, I guess, I think that feels a little funky. If you think of something stronger, let me know. And my representation is going to really be this. Factor, product, and above it's going to be rows, flowers in each row, and TF for total flowers. Over here, solving style, I'm gonna go to the T-chart. So achievement first does that factor rainbow. I do a T-chart, it should not have this line above it. I'm actually just gonna do it on the back right here. We're working with 18, and I'll model mine and theirs. So this is about consecutive understanding of factors, and so I'm asking myself each time, what number can I multiply this number against to get to my product? 1 times what gets me my product, 1 times 18. 2 times what gets me my product, 2 times 9. 3 times what gets me my product, 3 times 3, 6, 9, 12, 15, 18. We can have kids doing that. 4 times what gets me a product, nothing. So I cross it out in that sloppy way. 5 times what? Nothing. 6 times what? And then this is when you see the flip, the inversion. 3 times 6. 7 does not work. 7, 14, 21 definitely doesn't work. 8, 16, 24 doesn't work. 9 times 2, 10 times nothing. and I would need to go all the way to 18, but what you can figure out is once we double, and this is the doubling, because you see it right up here, then you found all the factor pairs. So your factor pairs are 1 and 18, or 18, sorry, and 1, 2 and 9, or 9 and 2, 3 and 6, or 6 and 3. And that's how we'd list them out. And because I messed up, I would come back here. I already created my list on the back page, and I will say I can have, there's 6 different groupings, 1 giant row of 18 flowers, 18 teeny tiny rows of 1 flower in each row, and so on and so forth. The factor rainbow looks like this. 1 times 18, then you go to 2. Here's the tricky thing. Kids have pencils, which is nice. 2 times what gets me this? 2 times 9. Next number I'd go to is 3. 3 times 6, 4. And here, this is where I don't understand what they're doing. I guess what they are doing is what you see right here, which we can pair with this if we want, but I think mine does both. So they're doing 1 times what gives me 18, 18, and then they make the row. So I'm actually gonna model that down here, so if I wanna make 16, start with this big row. So 1 times what gets me 16? 1 times 16. Once I can put 1 in 16. 2 times what gets me 16? 2 times 8. So 2, 8. 3 times what gets me 16? Nothing. 4 times what gets me 16? 4. So I could do 4. You're only supposed to do 4 ones. You're supposed to do a little arrow above it like that. I don't know. I don't love it. We need to do 1 model of it, and it needs to be paired with this. So asking yourself 1 times what, 2 times what, 3 times what, nothing. 4 times what gets me 16. That's it.